G'day. I'm ready to begin a little bit more plasma work. So I'm going to try and finish the garbage collector today. It might take a couple of hours, but we'll see how we'll go. I'll also take a break for lunch at some time. So I've changed my setup a little bit. So now I've got an IRC window, which you can see in the stream. So anything on the Plasma Laying IRC channel on Freenode will appear in the stream. Be kind, that usual rules. So now you don't necessarily need a Twitch account in order to comment, and when the video is uploaded to YouTube later on, the comments will be kept. Yeah, cool. So I'm going to finish the garbage collector, but first I'm just going to close another small issue that had been bothering me. So we're on the master branch and it's all good, and I think we're at the top and synchronized with GitHub. We are, so that's all good. So cool. Oh yeah, and the way I'm capturing the screens now means that there should be less flickering on the display, which should make it a lot more pleasant. So the bug I'm going to close is, I'll just pull it up. Just a really minor one. Actually, I'm not going to do it. I changed my mind. I'm just going to add comments into it to say how it could be done, because it is a good first bug. This one. Oh yeah, the issue comment already has enough information there. Also, the cons, the corresponding cons operation should be called creep. It's a bit more meaningful. Yeah. Where cons comes from the list construct operator in the list construct operator in Lisp. That's how it got its name. And snock is cons backwards. So snock adds something onto the end using a similar constant time operation. Let's edit. Hi, speaker. You've joined IRC during the stream, so I guess you found it from the stream. So now onto, so I'm not going to close that bug now, but now it's got enough information that somebody else could do it if they'd like to and have Mercury installed. Go back to working on the garbage collector. So I switched over to that branch. Pardon me. So tests p valid, make allocate. Good. So we got to the point last time where we had written the mark phase of the mark sweep collector. Now keep in mind it's a really naive collector. I made some notes. Here we are. It's a really naive collector. It's aimed at being the simplest collector we could possibly make in order to just move on to other tasks for now, because it's not important that it's efficient right away. We can worry about efficiency later. And I mean, I've got some plans with the garbage collector, so it's not like the first or even the second one will be the final version. It will probably be replaced or a lot in the future. So I'm just looking now for something that means that you don't unreasonably run out of memory. So it doesn't have to be pauseless or run fast. It just has to let you have some of your memory back. Now, so it's a mark sweep collector. It's non-moving for now. It's also conservative for now. That's something that will probably change soonish. It has to support interior pointers, which is something we haven't done so far. And it uses free lists and a bump pointer in order to get new memory. I was going to store mark bits and cell sizes in line. Cell sizes are in line; they're stored in the heap in the word before each cell. But mark bits and another type of bit, whether a cell is currently allocated or not, is not stored next to the cell. And that's so that I can, when given a pointer, I know whether the pointer is pointing to the beginning of a cell. I can find the beginning of the cell. Yeah, because if it's not pointing to the beginning of a cell, I can't mark it and assume that it's used. Also, yeah, they also let me sweep accurately. Otherwise, I wouldn't know how much to sweep. So, yeah. So let's go to marking, because I did not handle the case where there are interior pointers. So, is everything working? So the reason we need to handle interior pointers is because we tag pointers in Plasma. And so the low bits of a pointer can have some information about about the data type. And so we need to mask those off for the purposes of the collector. So what should we call the macro? think I need it in... I think I need to do it here so that is valid object and mark both work on their cleaned up pointer. Might as well dereference it there. And it's a field of that. So remove tag. Kind of not happy with those variable names. If I call, I mean that's the current stack item. If I make that I mean, because it's still kind of the current item, it's just been dereferenced. And again here. So now we'll write the remove tag macro. Remove tag is 0. It's the ones complement of 0, which is all ones, with the last 3 ones taken away. I just want to take the last 3 ones away. Remove tag of x. X and trying to just keep this simple. If you're hearing noises, that's the construction sites either side of my house right now. how many? Okay, so on a 64-bit system, we need to remove the last 3 bits. The last 3 bits is 1 plus 2 plus 4, which means it's 7. Now, C is going to expand this constant expression out to the right pointer width thing. I mean, I could have written it. Oh, I suppose I could write it out. It's fine. Doesn't matter. Else. And on a 32-bit platform, there are 3 tag bits. So that's... no, there are 2 tag bits. So that's the value 3. And that's why we can use the once complement and so on here, because that way we can just plug in the right thing here, and that'll get expanded correctly. Fairly sure if it assumes that this is pointer T. We can't compare against size of in the preprocessor. So what else is there? Runtime PZ common. Big common data format, using instruction directory, read, run, trace, util. Is it in here? Machine word size, is that align up? Is that? Put this on a different branch, this change. I don't even remember. You must be on a different branch. Well, let's see. I'm going to leave a tag I left, delete a tag I left lying around. Rebase from GC and do it incrementally. And right before I do this, say exec git merge no ff master. No, that's awkward. I don't want to do that. I'll do it here instead. Okay. What's what? Do I need the BSD source? I suppose I do. I would have introduced something that requires it. W error. Yeah, I made a bit of a mess of this. What have I got? Okay. So in this local branch, BSD source needs to be added, and dpz dev needs to be added. This for the debugging and the dev builds. And I need to go through well, not just the dev builds. I want that on the plain build for now as well. Until for whatever reason we, we may just delete that one. Whoop. I mean, what if I just delete that? That may be what I want anyway. I kind of want to make that 2 as well. See, my thinking is that for now, only people working on Plasma will ever compile it. at least in the short term, so I might as well set things up for them with some extra checks and things. Which is why debug is now defined, and maybe why pzdev is defined. But I can come back and fix that up another time. Yeah, that looks good enough. Now, are the changes that I was thinking of actually in here now? The changes that I'm hoping would appear. Yes. Good. Which gives me the clue. The macro that I've been using to detect the endiness of the word size of a system is word size. Which is good. So that works. That's not what I wanted. Yep. Happy with that merge, so we can commit that to GitHub. A mirror GitHub. And a local repository. And you can tell that it's live because it's updated in the IRC window. Okay. Let's rebase our changes. Actually, that'll... You know what? I'm not going to run the test suite because it's going to come back with the same error. I just want to build it for each change that I apply. Yep. Good. So now I'm happy with that, and I can use git stash pop. I could even do this without a macro. There. There, it's a sludge at the bottom of my coffee. Yeah. could even do this without a macro if I wanted, because I've got the word size. You could take the power 2 logarithm and do it that way, but I'm not going to, because I'm not exactly sure how to do that. Make a test. Invalid operands have void pointer and long unsigned int. So, and x. Oh, and there's a reason why we put any parameter that's used in a macro. When we place it on the replacement text of the macro, we put parens around it, because we don't know what it actually gets expanded to, and the evaluation order might be different. So it's always smart to put parens around it. Initialization makes a pointer from an integer without a count. Oh, right. Yay. So, I believe, yep, everything's the same as before. So that's good. We're now handling pointer tagging. So as I do each little bit of progress, I like to make a commit, and then I'll squish them up later to actually into coherent parts. And what's going on with my terminal? I don't know. Right, one sec. Fixing it. Okay. That should be right now. Okay, so now we're ready to write the sweeping code. Mark, collect, sweep. So we iterate over the heap for void cell pointer is void heap base address p cell must be less than heap wilderness pointer. There'll never be any memory to reclaim above the wilderness. In the wilderness, and the cell was. Now we're iterating over all the cells in the thing. First, we need to know: is this a set? Is valid? If is valid object. Heap p cell. Because that will tell us whether or not that that has been allocated. If it has not been allocated, it well, no, that's not right. Because we're always going to jump to the next allocated object after reading each one, because we'll know where it will be. We'll know where we can find it. Maybe I could have put the mark bits and so on inside the heap. If that's the case. Is between the base address, it has the bitmap allocated thing. That's what I care about. It doesn't actually matter. So there's also a mistake here. We need to move to the next slot, because the first slot will contain the size. The following slot actually is actually the value of a cell. So it shouldn't actually matter whether the cell is allocated or not, I don't think. Because if it is not allocated, in either case we want to put it into the free lists. And in either case, do we always know that we're pointing at a valid cell? I think so. What we don't know is whether the cell is marked. So, yeah, I think we're good. So we've got is valid. I'm going to use that, the one from below. Well, that's is marked. Yeah, can do. I feel better about that. If it is not marked, then we put it in the free list. And in both cases, we move to the next cell on the heap. So if our thing is not marked, we add to free So we need a free list. Wilderness pointer. Void. Free list. Is that what I want? Oh, please excuse me, my phone is ringing. That was spam. So, but I probably will go and get lunch soon anyway. So, sorry, I'm thinking about the phone call because it's somebody pretending to be my gas company. And whether or not I'm actually annoying my gas company by hanging up on them. Alright, if the cell is marked, then we add it to the free list. I was just thinking, do we actually want a better data type for the free list? But, you know what? Maybe. Maybe we'll type def a cell at some point. I don't know how useful it will actually be. I mean, we do that with SpiderMonkey, not a type def, but a C++ class, because then we can call methods on it, and it all gets type checked. It's kind of nice. But so I'm gonna do. Like I said, this is going to be fairly naive. We can merge cells later on. But for now, let's just throw them into the free list. And yeah. So pointer to cell. Into the cell, if the cell is free, is not marked, then we have it point to the next item in the free list, and then have, so we're pushing something onto the top of the list. Meanwhile, we get heap free list, and we let that be the current cell. And that's an interesting thing. Yeah, our free list point to holes. And we'll clear the allocated bits. The mark bit is already clear. So I program a lot less defensively when I'm doing it on the stream, because I'm definitely trying to keep things moving. So normally I would clear exactly the bits that I need here, but I'm just gonna, I know that for now the only bits that I have I can clear, but I don't know that I won't add something in the future. So and I don't know if you're watching last time, but that bitmap is not actually a bitmap. Everything's a byte, so I can just assign 0 into it without fear of clobbering anything. Add to the free list and move to the next cell. So moving to the next cell is heap P cell is the next one, which is P cell plus the size, which we'll get divided by, that's in bytes, we need to turn it into words, plus 1. And align up. Technically you could do all of it, but I'm going to do the actual part that causes the that could cause an unalignment, which is the cells. Ouch! Yeah, you do not want to do this, because the cell size is in bytes. That division will round it down, and then align up won't adequately fix that. So we could end up pointing at the one word lower than we wanted to, which could have been fun. So instead, let's do it in bytes. Is that what I want? Or if cell size was described in words the whole time. Which is, I think, what I'd actually prefer. For a lot of reasons. Okay, I'll leave that out. Pretend it's in words, which means we don't need to realign it either. Yeah, we're never doing any kind of cell merging right now, so the sizes will always be accurate, and we will be pointing at a valid cell, but that's quite fragile. Right. I'm going to save that where it is and change that cell size into words rather than bytes. And even change the allocation routine to take words. So, try allocate cell size. Try allocate size, cell, wilderness pointer. Yeah. machine words. Now, is there anywhere else? Yeah, okay. I was about to say, is there anywhere else where I can set the size? Here. So I read the size out. Divide by machine word size to get the, well, machine words, to get the number of words. And yeah, I don't need that there. You don't have to rename variables used in declarations. In fact, you don't even need the names there. They're just useful to explain to anybody reading the code what's going on. Runtime pz gc h pz gc alloc I call it in run generic. Is that all? I thought I had it in two places. Now, here's the tricky bit. I can't just divide by machine word size here. I have to add. Do I want to round up and then do it? Yeah. Size plus machine word size minus 1. So, what you get here is if it's already machine word aligned, say to 8 bytes, you're adding 7 because machine word size minus 1. And then dividing by machine word size, which rounds down, and you get the accurate number of words. If it was not aligned, so if it was already 1 byte off, you add machine word size, you get 8, and it rounds. Yep, cool. Stepping through it in my mind as well as explaining it. So this will round pzgc alloc uses size in machine words, round the value up. Good. I thought I was going to commit this separately, but actually it's going to get merged in with the other changes. Yeah, I didn't remember running make test. That's good that I checked. So actually, more likely to find it with Valgrind, I think. Invalid read of size 8. Easy run in line 770. So, dereferencing this value, the address that we get, which is a load address, yeah, which means we didn't allocate something correctly. Or reading something incorrectly, or something like that. Let's see what we get with tracing on. So, I believe that one of the things as developers we should be doing, particularly when you write any large system, is you partly want to build some of your tools yourself, such as debugging, particularly when the language support is quite bad. So, actually, yeah, which is why I write tracing things, and it's more than just sticking printf in the program. They are actually they stay there, they're committed in, anybody can enable them, so that it's just as easy as that to start having printf statements everywhere where you might be doing something funky. So it was having a crash dereferencing this value, which does look super high. So where did that value come from? Here. When it loaded it, no, it swapped it. It loaded it in second function. No, yeah. So let's look at where that might be. Make list, sum list, multiply list. Okay. Could be in make list, but I don't think so. There are no load instructions there. It's in one of these ones then. Yeah, so something funky is going to be happening. There's something funky with this 5 partway through this one. So this load 64 instruction. Yeah, it looks like some read is being offset there. So, in fact, there's a few. And they look like they're being offset by, what, a few bytes? So is it that my rounding up code didn't work? Something's going to be still in bytes whilst other things are in words. That's what it's going to be. So let's step through the code that we changed. So size in bytes plus machine word size or minus 1 divided by machine word size. No, I mean, that seems right to me. Break pz run generic. What line was it? 712, 712. 12. Run memory easy. Size is 16 and step into that. Is it step into or step over? I can never remember. Yeah. Step into. Size in words is 2. That's fine. Step. Easy PC 127. So here we are. Get the cell and the wilderness pointer. Print. Cell. We should also fill cells with zeros. Or yeah, I'll do that later. You don't need to fill cells with zeros or anything like that, but it's useful for debugging to make sure that memory when you first get it is clean. You could also fill it with some particular type of garbage to help with debugging. Yeah, and that'll be some build options that I have to tweak and set up. I thought I'd done that. I wasn't sure if I'd actually finished that or not, setting up different build options, but it looks like I'm still confused. Wilderness pointer plus size in words plus 1. And the wilderness pointer, what type is that? It's also useful. Another thing you're doing when you step through code is just thinking about it and working out in your mind what it should do. And there's our problem. Wilderness pointer is just a void pointer. So adding the number of words to it doesn't actually do the right arithmetic. It will be measured in bytes, not words or not units. If it were a double pointer, this would have worked. So instead I'll do a multiplication there. Write it anyway. Yes, make test. Tracing makes the test suite really slow, so don't do that. Instead, just run a test. Seems okay. Yep. I'll go and get lunch soon and be back later in the afternoon. Good. Looks like we're golden here. So fix up that little error, trim the white space. That one. Yeah, easy. fix up word size change. Yeah. Alright, now's a good time for me to go and get some lunch for myself. I'll see you all later on. I intend to stream actually a fair bit today to try and finish the garbage collector. That's the main goal of today. And we'll see. I do have some other things to do as well, some just life things. Yeah, cool. Take it easy.